Well, I have been thinking about creating a slide like this to explain a little bit on the exam, and here we go. So what my intent to work on this exam explanation is to identify what are the typical issue that most of you didn't actually get it, and at the same time will provide some information about what can be improved in the futures. So as you can see that we have 3 problems up to 300 points, and the test package consists of 8 pages, and each of the problem actually coming from each chapter, from chapter 9, chapter 10, and chapter 11. So as I mentioned earlier, that the best strategy for the exam, 50-minute exam, would be you have to do a time budget carefully, otherwise you would be running out of time. And usually when you look at the problem, you have to see which problem can actually bring you that you can actually start the problem quickly. That's the strategy. So next time for the exam 2, what you should do is look through this quickly and see which one you probably know how to start on the exam first, because 15 minutes is not really buy you a lot of time. So so let's see from the first question. So the strategy to begin solving the first question is to first understand what the question is asking. You have a load from the sending end Vs in this case, and then there is a line with a 0.5 ohms and J0.2 reactant, and feeding to 2 loads. As you can see here, is a 20 kilowatt 0.7 leading and then 12 kV 0.9 lagging. So you have 2 loads. Technically speaking, the voltage at the sending end should be higher than receiving end. So you have to make sure that you did it right by putting the right information on leading and lagging. So to do that, you have to first find out the current going through this first load and the second load. That will be equal to the total load sending from the voltage source. So to do that, you have to see what kind of information is given to you. So you can see that cosine theta 0.7 is actually the power factor. So to find out the angle is simply the cosine arc cosine 0.7 that give you 45.57 degree. By going through the tangent, you have 20k over Q, which is the reactive power. Right now you have the P, which is 20 kilowatt. Now the only component is missing is the Q. So what you can do here is to find out the Q, which 20k time multiplied by the tangent will give you 20.4 kilo VAR. So the next thing you have to do is the total complex power will be 20 J 20.4 kVA. So you have to pay attention about this sign, because if you don't do it right, you will get this wrong. So remember that we talk about this is that when you see a leading here, you should have the minus sign at front for the complex power. So once you find out the voltage here, and then you know the voltage at the receiving end, which is 250 volt, then you can actually put them together and find out the current for the first one. And don't forget about this conjugate, because it will lead to the wrong answer. Similarly, for load 2 is the same thing. So the power factors is actually giving 0.9 lagging. So you have to use cosine theta equal to 0.9 and then arc cosine 0.9 that give you the 25.84. So the same step you go through here. Make sure you have the right information. Lagging simply is a positive, and then when you try to find out the current, you have the complex power divided by voltage. A lot of you didn't do it right because you forget about the K, or you don't convert it into the right form. So you can either have the polar form of complex power or the rectangular form of the complex powers. So but again, that unit you have to be careful here, because if you don't put a unit, is different of 1,000. So by substituting all this, you have that I2 equal to 50 minus 25.84 minus here indicate the lagging. So we are actually doing this right. And the next step will be to add them out, the one here and the one here. So that will give you 143.06 with a degree of 26.2 ampere. Sometimes you get a if you don't do this unit right, you get a very high current, like 150 kilo ampere. I think that's ridiculous high numbers. So if you get that to this point, you have to make sure that you check out all the unit consistently for all the solution. Otherwise, it's going to go propagate the rest of the solution that get it wrong. Now, the second question is to find out the voltage source Vs. So this is pretty straightforward. You know the Vs, you know the current, which you just add it all, and then you know the impedance here, and then you know voltage. So simply find out the voltage, and the sending source will be the current multiplied by the impedance plus the voltage here. So if I see you get writing this formula, and then you probably don't get this current right, I probably will just give the full point here because you know what you're doing. The last question is to find out the power factors of the source. So we know the voltage, you know the currents. As you can see, that I actually designed the question so that you can find every piece of information from the source and the current. So power, complex power, is basically equal to VI conjugate. And the conjugate means that you have to put the negative sign here. So you have 235.54 with a degree of 7.03, and then multiply by the current here, 26.2. In that case, conjugate, you have to put a minus sign here. So that gave you 33.7 approximately kVA. So that's K is 1,000 here with a degree of minus 19.19. And when you substitute this number into the power factor, that gives you 0.94. So find a power factor basically is the cosine of the theta for the complex power, which is this minus 19.19. And then don't forget about the leading. If you don't put this leading in your power factor, the solution is not complete because you have 0.94 with lagging or leading, and you have to define which one is your solution. The second question would be basically make sure that you know how to define the directions of the current and voltage and the polarity based on the dot convention. We do it. Of course, there are many different ways to solve a circuit problem, but the way how I designed this question is you first have to assign the clockwise of the current directions, which is going through this 1, 2, 3, 4. So you have and then label the V1 and V2, which is V1 plus V1 V2. So once you've defined all, the next step will be you probably get a full point. And then when you get to the next question would be you have to consistently using the convention that you had to write out the 4 equation and the 2 ratio power transformer. So the 4 equation is actually correspond to each of the loop, I1, I2, I3, and I4. And then you have 2 additional equation which is coming from the voltage and the current, so that of the ideal transformer. The ideal transformer basically means that we don't have the power loss on that, and so if you write this right, you have a V1 divided by N1 equal to V2 divided by N2, but then so this is actually consistent with the plus minus out here, that how you define here. Something tricky about the current is that if you assign I1 getting into the dot, and so as the other one, and then because it will be a minus here, because when you put both of them on the left hand side, that will be positive on both sides. So you move it to this side, you have a negative sign. So so this is actually the same, V1 minus V2 over V2 equals 0, and same thing for the current, I1 plus 2 times I2 equals 0, 6. So if you do all this consistently, you will get that 60 point right away. The third question is basically writing all the equation from part B, organize it in a nicer form, so that you can see that this is I1, I2, I3, I4, V1, V2. So that's a 6 by 6 matrix. So this, and and then the only constant here is a 24 because you only have one source, which is right here, 24. So if you organize it and sum it out correctly, you should get a similar result like what I did here. This is a easy score, because as long as you get this right, you should be able to write this in the I1, I2, I3, I4, and V1 and V2 format. So this is the matrix format of part B. The last part of this question is really straightforward, because I know that you have a time limit during the exam, so I don't request you to solve this matrix for that 6 variable. So I ask, what is the V out in terms of that 6 variable? So V out, basically, since you define I2 here, so that will be V out equal to 1 ohms multiplied by the I2. And if you write this equation right, that's the free 5 points as well. Question 3, I am a little bit disappointed for question 3, because it is the easiest question for among the other two, because the first thing you have to do is to draw the phasor diagram for the current. So which is what I asked here. So this is consistently with what I give it to you for the class note, to have the line current and phase current defined. So if you do this right, you probably can just copy and make sure that is in the positive sequence, A, B, C, D sequence. And the reason I asked to draw this diagram is to make sure that you use this diagram to relate to other information that you want to convert into the Y connected format. So for no matter what configuration you have, delta Y, Y, delta, 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 you have to write in the Y connected form, so that you have to make sure that you do it right. So delta delta system, this is already in the phase, so you don't have to convert anything with 0.3 plus J 0.2 ohms. But the load, delta load, to convert into Y, you have to divide by 3, so you have 9 plus J6 ohm divided by 3. That give you the total of 3.3 plus J2.2. But for the line current here, IAA, which is this, you have to do some work, because the phase current IAB is equal to 40 degree amps, and from that you can see that IAB is here, so you have to minus 30 degree here, and then as well as multiply by square root of 3, because the line current is actually longer than the phase current. So that gives you square root of 3 times 15 with a degree of 10 ampere. So once you figure out how to this information works, so you have the VAN equal to IAA times Z total, that simply gives you the first voltage VAN at the sending end, which is what I'm asking for, is find the voltage phase voltages of the sources. So you have not only to have A, but B and C. Since the phase voltage will be equal to line voltage for delta connection. So this is really important. I say this a lot of time in the class, that delta delta, the phase current and phase voltage should be equal. So there is no conversion required at all. This is your final solution for VAN equal to 103.04 with a degree of 43.69. To find out the other two angle, for positive sequence, you basically have to minus 120 and then plus 120, and that's the solution for part question 3.